and we do not have any time to mess around. We have no time to waste on silly conversations and bullshit anymore.
Hello, everyone. This is Liz Parrish. She's the CEO of BioViva, the biotech company. And my name is Bobby, and this is Cyborg John. And we're...
John!
Yeah.
That's cool!
Yeah, because he has a really advanced wheelchair. He's a quadriplegic. And we're actually hoping throughout our YouTube channel, we could maybe, like, you know, on the 90th video or 100th video, he stands up through some sort of therapies.
I would love that.
To start, could you please discuss what sort of research your biotech company does, BioViva?
So what does BioViva do?
Yeah.
The short answer is we look to genetically engineer people to live longer and healthier and to cure chronic diseases, including the diseases of aging. And so, you know, this conversation that we're having here is, you know, plays fully into that. Hundreds of millions of people suffer every day with chronic disease. And then 100,000 people die every day of biological aging, and also children die every day from various diseases. And so when we look at these in a whole, what can we do about them? Well, it sounds like a really big problem. But actually, if we start to look at regenerative therapies, therapies that cause regeneration in the body, then we can start to get a glimmer of how we might create bodies that stay in homeostasis for a long time and repair damage like we were just discussing, instead of letting the damage sit in and it being a detriment to the organism. If you just heard a sound behind me, that's my dog. That was not my stomach. He's laying on the ground there. He's a Great Dane, and so if he makes some noises, that's him moaning and groaning over there. I'm not hungry, although I will be soon. So
could you elaborate on what reversing aging is?
Yeah. So what is reversing aging? Like, so what is the process? So there's biological aging and there's chronological aging. Chronological aging is getting older by years, and biological aging is the accumulation of damage. So we look at gene therapies that basically affect what's called the hallmarks of aging. There's several hallmarks of aging. There's 9 that are scripted, but we think that will shoot off to be about 10 or 11, and probably will be a growing list as we go. And these hallmarks are the processes that are actually driving the degeneration that happens over time and why we're diagnosed with certain diseases. So we can think about these, like a short list of these would be telomere attrition, mitochondrial dysfunction, glycation buildup, stem cell depletion. After you get in past that list, you start to get into some terminology that not everybody understands. So, but definitely, you know, come to our website and look at what the hallmarks of aging are. And these are the diseases of the future. So they're the diseases of the right now, but they will be what we actually diagnose people with in the future. So once science and medical doctors have all caught up with each other, we don't really just die of, let's say, heart disease. Heart disease is a culmination of several of the hallmarks of aging coming together and creating a catastrophic diagnosis that, you know, eventually we die from. And remember, people over the age of 65 generally have more than one disease, right? So we have diseases that are running in parallel. We might have, you know, heart disease, we might have a slow-moving kidney failure, and then also maybe have something like COPD on top of that. So rarely do people die with one diagnosis. They just die from one outcome, one disease.
That's not why it's important to target aging instead of like. I heard if we cured cancer like tomorrow, we'd only extend our lifespans by our average lifespan by like 2 to 3 years only.
Oh yeah, and there's a short list. If there's several diseases that if we cured that symptom, that one symptom of biological aging, we would just die of another, and they really insignificantly add years of life, considering that we're still accumulating damage and dying of other things. So we're still going to have a decreased ability to have a very good healthy body. So yeah, the reason why we would want to target biological aging is because it essentially has the best outcome for people. So if we were going to treat a symptom, why would we treat, LDL cholesterol if we could actually treat a symptom that was happening at the cellular level, like mitochondrial dysfunction and glycation end products? We can start to look at actually keeping these diseases from happening to begin with. If we start to target why we actually age and why aging then puts us at an exponential risk for disease, mortality and age are directly correlated, then we can start to get a handle and get a grip and create bodies that stay in homeostasis in a healthy state for much longer. If we look at biological aging, if we look at treating what's happening at the cellular level.
What are some of the most promising treatment your company is researching, considering age reversal and life extension technology?
Yeah, so right now we have shifted gears in order to help patients get access to therapeutics, and we are running bioinformatics. So we are looking at over 200 genes that are associated with aging over time. Those are one set, but we're also looking at about 59 genes that might be associated with longevity. But more importantly, we're looking at genes that drive regeneration. So right now, partners, we have 4 different therapies that are available. We hope to expand that to 10. So what are some of these genes that we're looking at? We're looking at HTERT, which is the human telomerase gene. It lengthens the ends of the telomeres at the ends of the chromosomes, creating healthier cell division, genomic stability, and it actually has a beneficial effect to mitochondria. So we're looking kind of at whole cell health and ensuring that cells can continue to divide and we don't have things like stem cell depletion over time. The second one we're looking at are myostatin inhibitors. So this is a gene, the follistatin gene. It increases muscle mass in patients with muscular dystrophy, and we're using it for an aging population. So as you get older, you lose muscle mass, and that's called sarcopenia. You might also lose muscle mass from that's called cachexia. It's from cancer therapies, and there may be a myriad of other reasons why you have muscle loss over time. And so this gene therapy predictably increases muscle mass in humans and in every animal model they used it in. And so we're using that for an aging population. The third one that we're looking at is Clotho. Clotho was named after the goddess Clotho, who spins the web of life. And it was the protein that Clotho creates was found to be in low amounts in patients with kidney failure. So in animal studies, they increased this protein and they found that it regenerated potentially kidneys. And it also had regenerative effects in the rest of the body. And it's associated with, one of the forms of it is associated with intelligence. So it's a really interesting gene to look at. And so we're using that one for kidney failure, chronic kidney failure, or renal disease. And then the fourth one is one that we're looking at now. It's called PGC1 alpha, and it is a gene that stimulates the mitochondria. It's associated with metabolism and energy, and it is probably going to be a great gene to use in patients who have obesity and are at great risk of type 2 diabetes. One thing that was interesting that was found about that gene, so if you look at metabolism of creatures, how fast they breathe, how fast their hearts beat, we used to think that creatures with a really fast heart rate lived a shorter life. They died sooner. And so if we look at that, we look at 2 organisms that are very similar, a mouse and a bat. a bat actually lives to up to 41 years, whereas a mouse only lives a couple years. And one of the key factors is a bat has PGC1 alpha upregulated in it. So we think that that gene might be pushing regeneration. So here's 4 genes here that are actually associated with longer, healthier lifespans in animals and model organisms. They might be beneficial to humans, but the list goes on and on of the genes that we'll look at. We'll look at senescent cell clearers and genes for macular degeneration that's age-related and things like that over the next 12 months.
Okay, nice. So extending a lifespan and reversing aging isn't only important because it ends a massive amount of suffering and, of course, keeps people alive, but there's also incredibly important economic implications, right? And I think it's well known that I've heard you talk about this, that by the year 2020, we'll have more people over the age of 65 than below 5 years of age. Could you discuss why that's so important and why that's something a problem that we need to solve?
Yeah, so the 5-year-olds go on to be the workforce. You know, they become 10 and 15 and then 20 and 25, whilst the 65-year-olds become, 70, 75, and 80 and become more and more indebted to illness. And so what happens is if we don't have enough workers, if we don't have enough skilled labor to pay the cost of the therapeutics that these patients will be undergoing, we have a catastrophic situation. And actually, this is already happening all over the world. So you're right. By 2020, we have more people over the age of 65 than under the age of 5. That's on the whole world. So this is still being vastly driven by countries who are still having more than 2 children, right? So many of the countries already are really suffering, and they're about to take a huge economic blow as the population continues to age and these healthcare prices go up. So not only does the population continue to age, we are living older than ever. So 1,004% more people will live to be over the age of 100. And so we know that these people are disabled and sick and have chronic diseases for a very long time. And we really need to ensure that they stay in the workforce for a longer period of time and that they're productive and active. And even when they're out of the workforce, that they're not a huge drain on, financial efforts.
Yeah, 2020, that's so soon.
Yeah, I know. It used to feel so far away, and now it's like it's right there. It's right on us, and it's really coming. And the economic burden is growing already. Countries are really struggling to keep pace with the aging population. We really need healthy people. So it's good. It's good business to create health. It's really good business to contribute to people having a better life and existing and being who they want to be and achieving the things that they want to do. That's already good business. But if we don't do it, it's going to break, the healthcare system. It's going to break the countries. The GDP just really can't keep up with the burden of this healthcare that's about to be upon us.
Jeez.
Really, it's going to be very bad in a couple of years unless we do something.
Yeah, we really need to do something. I think that the mother of necessity is one of the fantastic things that you see in Japan, where they are pulling out robots and things like that, and they have actually changed their regulatory system to reflect their dire needs. So their regulatory system works in a way that we'd like to see the U.S. regulatory system work, which is you take a drug, you pass it for safety, and then you can actually open it up for use to the population whilst you still continue to run phase 2 and phase 3 trials. And so this is an expeditious way to do medicine, and it's right in line with what we would like to do. So how we do it now, how we give patients access now is patients come through our partner companies and they have to go offshore for therapies. They have to go to different locations where doctors can legally, by consent and understanding, give them access to therapeutics. And that's a good way to start, because we can help get the data that will then show investors whether the therapies work or not, so they can invest their money in therapies that work. But we really then need the drugs to go to a regulatory system to get to most of the world. And in order to do that, we really like regulatory systems that offer the advantage of quicker access to patients, because otherwise patients die waiting.
Is this kind of one of the reasons why you risked self-experimenting with some age reversal technologies, because of these hurdles and these extra steps and waiting periods that you would normally have to go through?
Yeah, so we really, when we looked at these therapies and we looked at the promise of the therapies and thinking that we might be able to help, 7 billion people live a better, healthier, happier life, we really took matters into our own hands. So in 2015, we brought in the first investor into the company, and he understood that we would be using the money to run the first test in a human to treat biological aging. And I took both the telomerase inducer and I took the myostatin inhibitor. And the reason I took it is because I was the company leader. I was the visionary that had the idea that we could potentially cure biological aging, and so it was unethical for us to treat anyone else. And I really hope that we always in this company devise and make drugs through research and development and translate drugs that we believe are already for humans that I take. I want to do more gene therapies. I've been a test subject for the last 3 years, and I'm actually pretty excited about some of the new therapies coming out, and I'd like to participate in them. And I think that we should always make drugs that we would want to take as a company. I don't understand why we would make bad drugs. So yeah, I'm excited about it.
Nice. So I kind of see you as the face of gene therapies and using them to extend lifespan. And I'm sure in the future that's just going to increase so much more. During your advocacy, have you encountered a lot of bad critics? Because I talk to people about this all the time, and there seems to be a little bit of a stigma on gene editing, and even extending lifespan seems to be a problem for some people. But have you seen that?
Yeah, sure. I always listen. I think the most important thing to do is to listen. And if it's the same, so when I started this company, I was looking for cures for kids, okay? And I really, when I walked into longevity, I really didn't initially understand it right off the bat, quite honestly. I was like, I'm trying to help kids live a normal lifespan, and everybody wants to live forever in this group. And I was like, what is this? And then I had to wrap my head around it. So I had to realize that actually this was a huge opportunity to help kids. And, we can create a load of really great drugs for kids, since there's so many people who are suffering from biological aging. And many of these treatments that I've already told you about directly affect diseases that children have. And that is the beauty. So when I hear someone be critical, if it was the same question that I had, I know how to answer them because I insisted that somebody answer my questions. If it's something new, I really want to know, because I want to know, well, what is your concern? And let me see how I can answer that, or I can have some scientists answer that, or I can go do a bunch of reading, because it keeps me up to date. Also, when we get critical review in other areas, maybe in the science, I mean, it's fantastic. It's a great way to engage your company, ensure what you're doing is right, ensure that you still agree with your purpose, and steer your course. And so if they have critical suggestions of something that you can do better, you should definitely take those as suggestions. Some of those suggestions we've looked at and we've said yay or nay. We have changed things in the company to accommodate some of those suggestions. We definitely have better biomarker panels, and how we move forward as a company is definitely different than how we started as a company. But you also have to really not be insulted and realize when you can't meet people's needs. So when you say, if somebody just generally doesn't like what we do, well, I think what we do is very important, or I wouldn't do it. I don't imagine a day that I won't be doing it. And I know that you can't please everyone. So in that case, I'm going to continue to go on my course. So I'm a very difficult person to get my feelings hurt, and so I haven't yet. I've heard some weird things. I've even saw some things where people said they thought I was a man. Really, I actually read some of the things out to the company on company calls, and people in my company are totally annoyed. They're like, we don't want to hear this, but I laugh so hard. I think it's really important to have an open mind, take critical comments, and do with them what you can, and toss them if you can't. Because there's a lot of people who want to be critical, but they don't actually want to help. And then they might not be right? So when somebody comes to the company, they're like, you should be doing it this way. I'll say, well, then help us do it that way. And if they really don't want to, they probably have their own agenda, and they might not have known exactly what they were talking about. So, yeah, we're disruptive. I mean, even in the longevity group, we're disruptive, and that's going to rankle some feathers. But in the long run, they're going to be healthier for it. So we'll just keep on going.
Do you believe you will achieve indefinite longevity?
Indefinite longevity. I don't know what that would be, and so. As far as immortality, I mean, scientifically, you can make cells immortal by making them divide healthy divisions longer than they would otherwise. And that one way you do that is telomerase induction. So that's one of the things that we were interested in. So if you were in an organism and your cells divided longer than they naturally would, maybe you could call that some sort of biologically driven immortality, but something I imagine is going to be a problem in the future. I think that what probably made me unique in this area is that I didn't come in trying to live forever. I came in trying to find cures for kids, and I'm guessing that was why someone in the industry who wanted to live a long time hadn't already taken the gene therapies to try to do it, because it came with a risk, and I was okay taking that risk. So I didn't really get into this to live forever. I think that living beats dying any day, and I'm hoping that I would always choose for living.
Yeah, to be able to have that choice.
Yeah, I want people to have that choice, and I hope that I never become so depressed that I want to commit suicide. But unfortunately, there are people who do, and I would say that normally for humans always choose for life, and so that's why I don't get so worried when people say, "Oh, this science is against nature," or whatever. I know that they'll choose for it. Almost everyone on the planet will choose for it, because that's what we see in healthcare. When somebody's diagnosed with an end-stage disease, they spend 80% of all their money they would trying to get healthy, trying to beat their terminal diagnosis. And we can assume that they will continue to do that. And we can also assume that if the science is successful, they may not need to get to a point where that happens. But of course, other things will happen in life, like accidents and things like that. We can minimize that through automated cars and things like this. But as far as living indefinitely, I'm not even sure how to define that. So I don't know how to answer it.
Okay. Yeah, I can't imagine somebody at like the age of 100 or 110, if they're healthy, them just choosing the next day after they've spent their time with their family to just stop taking these treatments.
Oh, I can't ever imagine, I've been with people and they're like young people and they'll say, "Oh, I want to live to 78." And it's like, you will not want to die at 70. I'm sure of it. We choose for life. This is what we know, and we have no understanding of anything else. So why wouldn't we? So, we have to, we can talk about that, how important that is for us for life today. It's important that my children are alive with me today. It's important that you guys are alive with me and we're having this podcast today. It's meaningful. It gives us meaning. We're connecting. And I don't want anyone to regulate that away from us. So when people look at our company and they say, well, maybe this is too far out there, it's not. We're not fast enough. I know we're not fast enough. We're gonna lose a lot of people before we're done. And they don't understand how important that is because they don't have a diagnosis, because they don't have a chronic illness, and they are missing the point. The point isn't that suddenly tomorrow they're going to have to deal with people who live, indefinitely. The point is it's going to take a lot of days, a lot of tomorrows to actually get a therapy that is working in humans, and we do not have any time to mess around. We have no time to waste on silly conversations and bullshit anymore. We have a massive limit on the amount of viable days that I can work productively for you to create this world. And I need you to work with me, in your case, disseminate information, in a scientist's case, work on therapies that actually are working at a level that we need them to. And then it just goes on and on from there. It's really, really important that we take it incredibly seriously.
Yeah, that's great. So we see a few treatments out there, like metformin and rapamycin, and a few of them are actually really cheap. Like metformin's like 5 cents a pill, and rapamycin, I heard there's a pharmacy in England that sells it like $60 worth, or 14 weeks worth for $60. And I mean, these seem like, I bet we'll start seeing people live to like 110, or 120, 130 people who are taking these therapies to extend lifespan. How long do you think gene therapies are going to take to become affordable for the masses?
So you're talking about senolytics, and senolytics are drugs that have been around for a long time. And with those drugs, we do see some lifespan increase, but of course we don't see significant increase that we would like to see, that we expect to see with gene therapies. So I'm really glad that metformin is a viable drug for most people with very few side effects. That's fantastic. Unless you have renal failure. If you have renal failure and you're taking metformin, you need to be more careful. But for most people, those are really low-lying fruit, and they are inexpensive. But their output in the long run compared to the gene and cell technologies will be significantly small. Yeah. And that's a great thing. So they might be a good intervention now. And rapamycins, depending on what rapamycins you're taking, can have some off-target effects. But I would still say they're probably metformin being the safest drug that you can take, and I can't suggest anything else outside of that, except for I expect you to jump straight to gene therapy. And and so gene therapies will take a while to become affordable, but the more people who take them, even now, the larger groups that we get who will take a gene therapy to treat a specific condition, brings down the price significantly. And when I did my therapy, we pinned those prices of whole body transduction of gene therapies to be valued at well over $1 million. Now, the most expensive therapy that we look at is just near $1 million, and actually they're coming down quite quickly. So through the regulatory service, the gene therapies we're seeing are massively cost prohibitive. So the last gene therapy that was passed in the U.S. for congenital blindness is $850,000. But quite honestly, a therapy in a medical tourism type route of that caliber could be given for under $100,000. So, there are a lot of cost savings to be had already, and we just need to get that information out there and get the payers who can afford to participate, get the pioneers, the risk takers, and the terminally ill, and get them in there, participating in these therapies, and so that we can actually build the future for the rest of mankind. And when we have therapies that actually work, if we were looking at treating thousands and then millions of people, the cost becomes negligible. It just really is having enough manufacturing for it. I mean, at that point, it should not be expensive technology. At that point, it shouldn't be much more expensive than a doctor visit with an immunization on top of it, maybe a couple $100 per person, and subsidized in other places of the world so that even people with lower incomes can have access to them.
Yeah.
Cool.
Hopefully the U.S. government at least starts funding more of this research.
Yeah, we have to, the most important thing is to just prove that it works in humans. And so that's what our platform, our bioinformatics platform, is about, is to get that human data. You get their data before, you understand exactly what therapy they're taking and what part of their body and how much they're taking, and then you look at the data after. And we're hoping to get a lot of innovative partners in on this endeavor in order to have really good data that we can look at and see where it's working in the body and where it's not working in the body. We don't need any more pass or fail drug systems. When you have a pass or fail drug system, companies hide a lot of bad data. They only show the good data and the endpoint, and then you end up with all these side effects in patients. What we just need is clean data. Where does it work? Where does it not work? And what drugs can we start to combine with this in order to shore up the whole pipeline?
Is that a part of the reason why you're launching that blood and DNA testing October 19th? We saw on your website.
Yes. Oh, thanks for noticing. Yeah, not many people go to websites, it seems like, anymore. But yeah, so we are launching a SNP testing that will look at a large number of SNPs. And so when you look at your whole chromosome, it has about 3 billion base pairs. And so that's just a base pair, an A and a T, a C and a G. And in people, over time, we've noticed that there are little variations in those base pairs. And so instead of an A, someone might have a C, even though most of the population has an A. So how do we use that? One way that they use that early on is to look at lineages. Who's your family history? And maybe in forensics, and to, who is the criminal here? Does the family have an outlying SNP? But now we look at them as having some sort of implication in your health risks or benefits. And so the SNP testing is exciting. It gets people sort of looking at their DNA. People have been doing that with various products already. And so with this, we're launching something else called genomic counseling. So let's say you don't want to take our SNP test, but you've already had your 23andMe or, your other genomic tests taken. You can actually come to us and use our genetic counselors to look and see what that data means. And if you're concerned about something or you don't understand one point of your testing, people can come through and do that. Another product that we're hoping to offer pretty soon is DNA methylation. Some of the tests where they can look and kind of scout out how old you are based on your methylation profile. So BioViva is doing some things that essentially are just there to get people excited. They're not big profit margins by any means for our company, but we want to get people excited. We want to get people looking at things and, expanding their mind into technology that they might want to partake in the future, and that would be gene therapies and gene editing.
Okay.
So, in our minority in science overall, have you experienced any oppression or discrimination in your adventure in this kind of esoteric branch of science?
Have I experienced being a woman in, yeah, well, sure. Yeah, I know several male CEOs of biotech companies that don't have let's say a biology background, or they're not a medical doctor, and yet it seems like most of the interviews that I do, they'll say, wait a minute, you're not a medical doctor, how could you be doing this? And I'm always like, what? You never ask my guy friends that. So I feel like I'm always having to like defend why in the hell I could have the audacity to want to make the world a healthier place. And that's kind of funny. I have noticed that, but I mean, I think I mean, yeah, I don't want to complain too much. The best thing you can do is be a success, to show that, you know, you're in here for the long run, and to not get too bothered. But I have been asked some questions that I think that my male counterparts don't get, but that's okay.
Yeah.
I'm kind of an Amazon-sized woman. I'm not like someone who's easy to walk over. I was raised with brothers, and so like I don't get into weird situations one-on-one with people, because I think I probably am a little bit of a linebacker of a woman. Yeah.
No, it's pretty cool that you actually went to the risk of experimenting, you know, on yourself. You know, a lot of people would go through that, but that you feel so strongly about your cause that you did it. And it reminds me of a story about the guy who stomach ulcers. The main cause of them was a bacteria. For the longest time, they didn't know it. And the guy was like, I'm telling you, and it's like Heliobacter pylori, I believe. He's like, it's this one, and then they didn't believe me, so he's like, fine. He took some, he injected it, and he got the ulcer. And he's like, see? So,
yeah. Thank you. And you know, actually, so there is one interesting story there that I never talk about. Oh, doo-doo. When I did the gene therapies, everyone that I worked with didn't know that I had kids.
Oh.
And the benefit of that is that I was never attacked by the media for being too risky, and you know, all of the attacks that I would have gotten for being a woman with children who then went out and took a risky therapy. It was over. The story was over. It was already done when the media found out. And I think they would have raked me over the coals. Whereas if the kid's father would have done it, they probably would have sung him like a hero. And so I do believe that I would have gotten a lot probably attacked if I would have announced it before I did it and announced that I had kids. And actually, the people that I worked with in the company, they did not know that I had kids, because it was important to me that until after the therapy, I didn't look like I was just a mother, you know, making my last stand, you know, trying to help my kid. I'm trying to help every kid. When my son was in the hospital with type 1 diabetes, I saw kids that died of other diseases, and we have to like put down our prejudices and our bullshit about who you are and who I am and what my role is in society. My role is anything I want it to be, and so is yours. You know, we can't live in this world anymore if we're limiting each other and we're judging each other. You know, that just doesn't make sense. And so that was one thing that I did. I did not talk about being a mother until the therapy was over.
Wow, that's incredible. Well, that's all our questions we had. Thank you so much for talking with us, taking the time out of your day. And we look forward to talking with you more in the future.
Yeah, have a wonderful evening, and thanks for making time. And I know that it took us several times to get to this point, and I hope that your podcast turns into something awesome.
Yeah, thanks a lot. We look forward to living with you for thousands of years.
I am such a mom. I'm going to come over and be like, okay, have you cleaned your room? Have you changed your genes? What gene therapy did you do this week? Did you know you're a little bit behind on your gene therapies?
Yeah. Awesome. All right. Well, have a nice day.
Okay. Bye.